A galaxy without stars. Seeing the wake of Betelgeuse's companion, a privately funded Hubble-class telescope. And could there be exomoons at TRAPPIST-1? And on Space Bites Plus, seeing an event horizon in 3D. All this and more in this week's Space Bites. We've seen galaxies that have an excess of dark matter and then galaxies that have a low quantity of dark matter. And now astronomers seem to have found a galaxy that has no stars. It's just dark matter and some gas. It's a failed galaxy. So this object is designated Relic 1, or the reionization limited H1 cloud, where the H1 stands for neutral hydrogen. And neutral hydrogen is the raw material for forming stars. And this object was originally discovered using China's 500-meter aperture spherical telescope, the FAST telescope. And they were detecting the presence of a cloud in orbit around the spiral galaxy Messier 94, which is relatively close to us astronomically speaking. And so they didn't know what this object was. And so they did follow-on observations with the Hubble Space Telescope, and they detected the presence of only gas, no stars. And so you've got this object which has the surrounding dark matter that is concentrating material together, like there is a halo of dark matter around pretty much every galaxy in the universe. And yet it wasn't enough to bring this gas together to the point that could actually form stars. And astronomers are calling this Cloud 9 because it's the ninth of these clouds that were found orbiting around M94. But this one doesn't seem to have any stars. This is the first time we've seen a galaxy that is just gas, no stars. And yet, when you sort of think about the distributions of dark matter that must be out there, how it's lumpy in concentrations, there must be more of this out there in similar configurations. We've got a great story about this from Evan Goff on Universe Today. One of the longstanding mysteries of Betelgeuse is its variability. And it actually has two cycles of variability. One cycle is very easy explained. It is a enormous red supergiant star that's in the last throes of its life, probably in the last million years. This causes it to pulsate in a way that is very recognizable and happens with a lot of these supergiant stars. But it has this second oscillation that lasts about 2,100 days. And astronomers were having a really hard time figuring out what was causing this. But one really intriguing theory is that there is a companion star that is orbiting around Betelgeuse. And when that star passes in front of Betelgeuse, then it slightly dims the star from our perspective. And the telescopes watching Betelgeuse are so good that they can measure this variation in brightness as it happens every 2,100 days. And then astronomers actually discovered the object. We reported earlier this year where there are observations of it directly. Probably. And now astronomers think that there is a sun-sized star, a sun-like star that is orbiting around Betelgeuse. It takes about 2,100 days to go orbit, which is just outside the atmosphere of Betelgeuse itself. That star is so big. And now astronomers use the Hubble Space Telescope to watch Betelgeuse during the transit of the star passing in front. And they were able to detect the presence of the wake of it passing in front. So when you think about it, you've got this giant star, Betelgeuse, and then you've got this other star passing in front of it. And as it does, it's so close to the atmosphere of Betelgeuse that it's causing this gravitational wake on the surface of Betelgeuse that was detectable by the Hubble Space Telescope. And they were able to sort of measure the movement of this star as it was passing in front of Betelgeuse. The companion star, which people call Betelbuddy, is currently behind Betelgeuse, but it's expected to reemerge in 2027. And so you can expect that astronomers are going to turn their telescopes again and try and catch it as it emerges and take more images, because like the best time to be able to see it is when it's on either side of the star, not when it's behind it, obviously, or when it's in front. Both are tricky. So whenever you get a new telescope like James Webb, you discover entirely new classes of objects. And I think one of the most famous of these are the little red dots, which we've done a lot of reporting on, and astronomers are slowly working out what these things are. And now at the new American Astronomical Society conference, astronomers presented another mystery object. And so at the press conference, the astronomers called this a platypus. And right now, astronomers are genuinely puzzled at what these things are. So on the one hand, they're tiny and compact, but they don't see the characteristics of a quasar. They don't see it behaving like an actively feeding supermassive black hole. And how they found this is pretty cool. They just took a giant survey of data from James Webb, identified 2,000 point sources, and then they categorized all of the ones that they could. And once they had gone through all of them, they were left with 9 objects that were located between 12 and 12.6 billion years ago that they just couldn't identify. This spectra produced by the astronomers using Webb shows you the comparison of what this object looks like compared to the normal spectra of a quasar. It's a very different spectral signature. And so it's still possible that these are some kind of active galactic nuclei. Maybe we're seeing it at a different angle, or maybe it's surrounded by dust in a different way, but those have been seen as well. And so, if it is an active galactic nuclei, the astronomers say, well, it must be a new type that we've never seen before. And so this is just like a genuine mystery. We have no idea what these things are, but I'm sure this is how it begins, right? Astronomers find a new object, they say that's funny, and then they do follow-on observations and slowly work out what it is. It's what we saw with fast radio bursts and dark matter and dark energy, and this will be another one of them. We got a cool announcement last night from the ex-Google CEO, Eric Schmidt, about 4 observatories that he and his wife are planning to fund. 3 of these are ground-based telescopes, and 1 is a space telescope. So I'm going to start with the space telescope because it's kind of the coolest idea. And they're calling the telescope Lazuli. And so this will be a 3.1 meter space telescope. And you compare that to the size of the Hubble Space Telescope, which is 2.4 meters. It'll be on a highly elliptical orbit, getting as far away from the Earth as 275,000 kilometers away. And that's great because, we're seeing problems with both ground-based telescopes having to deal with these mega constellations. And even the Hubble Space Telescope is losing some of its observations because there are satellites passing through its field of view. It is orbiting in low Earth orbit. It's going to have a wide field camera, a spectrograph, and of course a coronagraph, which will allow it to block the light from the stars that it's looking at and hopefully be able to reveal exoplanets that are orbiting nearby. They haven't announced who's actually going to build this thing, what it's going to cost. But still, it's kind of exciting that, a billionaire is putting down money to help fund a telescope. This is the new race, billionaires. This is how you prove that you are an important person, is that you build really fancy telescopes and you make the data publicly available to astronomers everywhere. And then there are 3 ground-based telescopes that they are proposing. One is an array of 1,200 telescopes with 11-inch mirrors, and this is called the Argus array. Another is an array of 1,600 radio dishes in Nevada called the DSA radio telescope. And then the third is called LFAST, and will use 20 80-centimeter mirrors in a single rack, which will make it the equivalent of a 3-meter telescope. And a lot of these ideas of sort of like putting together smaller consumer telescopes, we've seen this work really well. There's the Dragonfly telescope, which is a bunch of consumer telephoto lenses bolted together. You're seeing ways that you can use new technology to make these telescopes work when you've got lots of separate parts. So it's interesting to see whether and how many of these telescopes actually get built, and actually if the Lazuli telescope actually gets launched, that'll be amazing. So Europa is one of the most interesting places to search for life in the solar system. And people often ask me, like, where would you look for life in the solar system? Is it Mars? Is it Venus? No, it's probably Europa. Well, probably Enceladus, because we know it has a liquid water ocean, and we know that it is spraying that material out into space. But Europa seems to have this thick shell of ice, and then underneath that is a deep ocean of liquid water. And when we look at Io, the place is covered with volcanism. It is very hot. And when you think about Europa, we see these cracks on the ice. It is not as close as Io, and yet it probably has the same tidal flexing that heats its interior. That causes the interior ocean to stay melted. And then that could be a place for life. And when you look on Earth, we have these hydrothermal vents where you've got a completely separate ecosystem from what you see on the surface of the planet. That if the surface of the Earth was rendered uninhabitable, you would still have life down at the bottom of the oceans. And so it's believed that there is something similar happening on Europa. You would have some kind of volcanic activity as well as you have the water. Well, a new paper says not so fast. The problem is that you need to have faults, places where you've got the ocean floor cracking open so that this hotter material can make its way from inside Europa out to the surface. And researchers went and did a bunch of simulations looking at all of the possible ways that you could get faults. They looked at tidal flexing, they looked at global contraction, they looked at mantle convection, and even something called serpentization, which is where rock absorbs water and then creates an exothermic reaction that can raise the temperature high enough that you actually get these vents. And none of these mechanisms would work on Europa in a way that would allow you to get these hydrothermic vents. And so, according to their research, you just can't get those hydrothermic vents on Europa. We got to start about this from Evan Goff. So supernovae are rare, and gravitational lenses are rare. But what's even more rare is when you get a supernovae that is magnified by a gravitational lens. And whenever they're found, they're extremely exciting. And now astronomers have found a new one. It's designated SN 2025 WNY. And it appears that it went supernova when the universe was about 4 billion years old. And then the light from the supernova was lensed by a pair of foreground galaxies. And what you get is that the light from the supernova takes a couple of different paths as it goes around the lensing galaxy pair. And that gives you different timing. It's kind of an amazing thing that you can actually watch the supernova over here, and then you can watch it over there, and then you watch it over there. And over the course of some length of time, you will actually watch the entire supernova unfold over and over again. And so you get this magnification. It's about a 50 times magnification on what you would see if you just tried to look at it directly with, say, the Hubble Space Telescope or James Webb. But you also get this independent measurement of the Hubble constant. And this is one of the most exciting reasons why astronomers are always looking for these supernovae going off behind gravitational lenses, because the light has to follow a different path around the lensing galaxies. And from that, they're able to measure the expansion rate of the universe, which is amazing. And from that, they're able to confirm which of the measurements of the expansion rate of the universe is more accurate. We've got a story about this from Matt Williams. Every week we do a vote on our channel where you tell us what you thought was the best story of the week. And the winner last week, actually 2 weeks ago, because we didn't do a show last week, was that there was no ocean for Titan. Instead, it's just a giant slush ball. So thank you everyone who voted last time. We're going to put the vote for this week's episode into the post tab here on the channel. So go ahead, take a second, vote when you see it, or go into the post tab, search out all of the previous polls that we've had and just vote. And that will train the algorithm that you want to see more of these. But definitely subscribe to the channel and click on the notifications bell to get more updates. We talk a lot about how dust on the moon is going to be a big problem for lunar exploration. So when the Apollo astronauts went to the moon, one of the things that they reported was that this dust got everywhere, got into their machinery, got into the joints on their spacesuits, and it even got into their lungs. They were having like a cough caused by the lunar regolith. And so understanding this dust, mitigating it, is a big priority for anyone who is planning on going to the moon. And so researchers in China have developed a theoretical model that helps explain how these charged dust particles interact with spacecraft surfaces on the surface of the moon. During the day, the surface of the moon and all of the spacecraft are pelted with ultraviolet radiation. This strips electrons from the spacecraft and the lunar surface, and so that makes them positively charged. And then at night, they collect electrons from the surrounding plasma that is around the surface of the moon, and then that makes them negatively charged. And then you have the things that are positively charged meeting with the things that are negatively charged, and they will attract this dust to the spacecraft. Once it attaches to the spacecraft, then another force takes over, which is called the van der Waals force. And this is very strong, and it means it's very hard to remove this dust. Even just like brushing it away doesn't work very well. And so the researchers simulated all of the mechanisms that are going on, built this model that explains how this works, and then predicted what kinds of surfaces would work best when you're on the surface of the moon. They actually found that rough surfaces work better than very smooth surfaces if you want to try and minimize the amount of dust that gets attached. And then they also found that you can predict which parts of a spacecraft are going to pick up more dust. And so if you do have some kind of mitigation, or you have like a limited kind of like an electrostatic shielding that you're going to put on your spacecraft, you can concentrate it into those places where the dust is expected to actually be deposited. We've got a story about this by Mark Thompson on Universe Today, and it's great because it really goes into the detail of all the individual steps that happen with this lunar dust. If you're interested in this problem, you should definitely check out the article. The TRAPPIST-1 system is the most exciting planetary system that we've found so far. You've got 7 Earth-ish sized worlds orbiting around a red dwarf star. At least 3 of them are in the habitable zone of that star. But a question is, could any of those planets have moons? Now, none have been observed so far, but researchers wanted to estimate whether moons would even be stable. Because the thing to keep in mind is that because the TRAPPIST-1 worlds are orbiting around a red dwarf star, they are very close. And so they interact with each other with their gravity. And you have these 7 large worlds interacting with each other. And so you've got some constraints. The first constraint is what's called the Roche limit. So this is where the tidal forces from your planet are going to tear a moon apart. You have to be outside the Roche limit. But then you've got what's called the Hill sphere. That's the distance from a planet where it can capture an object and have it remain in its gravity well and go in orbit around it. If you're too close, the moon gets torn apart. If you're too far away, the moon just goes into orbit around the star instead. But because of the interactions between the planets, there's more chaos. And so the researchers did a bunch of simulations where they tried to figure out what kinds of moons could be stable and survive. And they found that large moons would tend to spiral inward, but if you had small moons and they were relatively close to their planets, they could be stable. And so we probably won't expect to find very large moons orbiting around the TRAPPIST-1 planets, but there could be small moons. We've got a story about this from Mark Thompson. In 1604, the German astronomer Johannes Kepler spotted a new star in the sky, a supernova. And not just any supernova, but it turns out this is a rare form, a type 1a supernova. And we talk a lot about these here on the channel, but this is where a white dwarf is pulling material from a companion star and then it just detonates. And researchers have been observing this object for a long time, but they've been using the Chandra X-ray Observatory since the year 2000 until now, 2025. And with a quarter century worth of observations, they've been able to stitch them together into a time lapse. And so you can actually watch actual clouds of material that are moving away from the center of the supernova. And it doesn't look like it's very much distance when you look at it, but keep in mind that it is a huge object. We're talking light years here. And so some of this material is moving as fast as 2% the speed of light. And we are watching this explosion unfold over the course of 25 years. I've got a story about this from Matt Williams on Universe Today. In 2019, we got our first image of the shadow of a black hole event horizon. Of course, this was the famous image taken by the Event Horizon Telescope. This is a virtual telescope made up of radio observatories across the world working like one giant telescope. And then 3 years later, we got the version for the supermassive black hole at the heart of the Milky Way. And the problem is that we're out of targets, that those are the only 2 large supermassive black holes from our perspective in the sky. But astronomers have been continuing to gather data And a new plan is to work on a 3D image of the supermassive black hole to understand all of the magnetic fields that are surrounding it and how plasma moves around this supermassive black hole and leads to the jets that we see coming out of the galaxy M87. And so astronomers are now working on a multi-year plan to gather the data and build this model or this image, like a video of the environment around the supermassive black hole at the heart of M87. We've got a story about this from Mark Thompson. This is just a fraction of all of the stories that we cover on Universe Today. And in fact, we write between 30 and 40 stories every week over on Universe Today, covering a lot more material. And we don't have time to cover it all here on Space Bites. But I write a weekly email newsletter that gathers together all of this news. I write every single word. There's no ads. It's completely free. Go to universetoday.com/newsletter to sign up. We're doing something completely new for 2026, and I will talk about it in a second. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Bear Lake Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Bailock, Cy Nelson, Dark Finger, David Gilton, David Matz, Evan Pro, Greg Feely, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Josh Schultz, Marcel Smith, Michael Purcell, Nordspace, OneStepForAnimals.org, Paul Robach, Ren Kaidu, Richard Williams, Sean Sargent, Steve Fowler Munley, Team 49, Telescopes Canada, Wolfgang Klotz, and Zelda Ward Galactic Defender, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. Now, as you know, I will sometimes rant at the end of Space Bites or the question shows, and we thought we would give the patrons a chance to direct my rants in directions that they think might be useful to society. So we're calling this a pile of spice in that, whoever controls the spice controls the universe. In this case, I guess I'm the universe and the patrons are controlling the spice. But anyway, so we got this question from Klemsky. As a Canadian, are you into hockey or any other sports? Considering your busy schedule and hobbies we know of, are there other interests of yours that you would like to explore more or get into? Any hidden specific YouTube areas that you sometimes watch? So my eternal shame is that I do not watch hockey, that I have never really watched hockey. There was like one season when the Vancouver Canucks were doing well and I jumped on the bandwagon and watched the playoffs and it was fine. It was exciting and we got very close to the end. But just like in general, no, I don't watch hockey and I really don't watch any professional sports, but I participate in a bunch of sports here in Canada, and where I live on Vancouver Island, we're renowned for the mountain biking. And so the thing that I've done the longest in my life is mountain biking. I started mountain biking like literally when these kinds of bikes were first invented or shortly thereafter. And so I think I got my first mountain bike in the mid 1980s. I think I was like 15 or so. And where I come from, the small island, Hornby Island, we would do a ton of mountain biking. We've got like world famous trails. And where I live now in this city called Courtenay, we have this place called Cumberland, which again has world famous mountain biking, that the city is buying up more and more chunks of the mountains around us and turning them into mountain bike trails. And so everybody has a mountain bike here. We spend more on our mountain bikes than we spend on our cars. And I love the question about like the secret YouTube. So yeah, I totally do. I watch a bunch of stuff that is related about science fiction. I don't watch a lot of space stuff because I sort of do that as my day job. But the thing that I really enjoy is nature restoration. And so there are a bunch of people who are attempting to recover land or add more biodiversity to their property. This is one of my biggest hobbies where I live, is that, we've got this old piece of degraded logging land that I am trying to increase the amount of biodiversity, bring more animals and birds and plants and fruit in the forest that I can just walk around and feast on. And so a bunch of the channels that I watch are related to that. One of these is called Dust Ups by a guy called Sean Overton, who is in Texas and is restoring a piece of desert. And we have the opposite problem. I have too much rain. He has not enough water, but it's great to watch his trials and tribulations and how he's just learning on the job, which is very similar to what I do. And then the second channel, which I found absolutely inspiring, is the Wildlife Homestead, which is a guy out of Quebec who has been working on upgrading his land for the last 3 years and has just brought in so many different kinds of mammals and birds and plants and amphibians, but does just an incredible job of the cinematography. I am so jealous, and it really makes me want to get out there with trail cams and better gear and better technique and show you guys the kinds of animals that we're seeing here on the property. We got elk for the first time last year. And then the last channel that I like is Wilson Forest Lands, which is a logger who is sort of teaching me ways to be safe as I cut down trees and how to sort of manage my land. Not for selling wood, but for just trying to increase the diversity. So yeah, if you go back through my YouTube history, you'll see a lot of videos about people restoring land and increasing biodiversity, building ponds, that kind of thing. That was a very tame topic, not even a rant, but if you want me to go off on any topic, we'll put a link in the show notes. You can go and add to the pile of spice, and I will consider your suggestions for future videos.